A very important question from CBSE examination point of view. Exercise 1.3, question number 1. Prove that root 5 is irrational. So you can have question prove that root 2 is irrational, root 3 is irrational, root 7 is irrational, and so on. Different type of numbers can be there, but the process method is same for all the questions. To prove that root 5 is irrational, we will use the method of contradiction. Now, contradiction method means that whatever you have to prove, you will assume that its reverse, its opposite is true. Or whatever you have to prove, you will initially assume that it is wrong. So let us suppose we have to prove that root 5 is irrational. We will say root 5 is not irrational. First statement, let root 5 is not irrational. If root 5 is not irrational, then what it is? It should be rational, because either the numbers, categorize them real numbers into rational or irrational. So here, if the number is not rational, that means it is irrational. If a number is not irrational, then it is rational. So root 5 is equal to a upon b, where b is not equal to 0. Now root 5 is squaring both the sides. Five is equal to a square upon b square, cross multiplying a square is equal to 5b square. Let this be equation number 1. Now, a square is equal to 5 into b square. That means 5 is a factor of a square. Therefore, a square has a factor 5. Now, if there is a number, its square is having a factor 5, that means the number should also have a factor 5. Now, suppose there is a square number. Square number, say it is what? 625 is a square of some number. So this number has a factor 5. If I say this number has factor 5. So if there is any square number, take any square number that has got a factor 5. Another square number which has a factor 5 is say 25. It also has got factor 5. The square number. So 25 is what? 5 is square. So if it has got factor 5, 25 has got a factor 5. So the number whose square it is, that is 5, also has factor 5. Its factor 5 square, its 25 will have factor 5, 5 square is factor 5. That means if there is a number whose square has a factor 5, the number also has the factor 5. Similarly, here 625, that is what? Square of 25. This 25 is what? 625 is what? Square of 25. 25 is square. So 25 square has factor 5. So 25 also has factor 5. So if a square number has got any number factor, say a square number has factor 2, so the number also has factor 2. Now this concept is to be used here. Now 625, a square has factor 5. Therefore, a also has a factor 5. Now, if a has a factor 5, this means a can be expressed as 5 into k. Placing this value in equation number 1, we get 5k square is equal to 5b square. 25k square is equal to 5b square. Now here 5 will be cancelled here. 5 is 25. So b square is equal to 5k square. You get another relation here, that is your second relation. Now b square is equal to what? 5 into k square. So b square has factor 5. B square has a factor. 5 is a factor of b square. So b square has factor 5. As factor 5. B square has factor 5. Therefore, B has factor 5. Now you see, A has also, we have proved that A has factor 5, B also has factor 5. Therefore, 5 is a common factor between A and B. 5 is common factor of A and B. But A upon B means if there is a common factor, it would have been cancelled. It would have been cancelled before. That means there is no common factor between A and B. But there is no common factor between A and B. So there is no common factor between A and B. Hence we arrive at a contradiction. The contradiction is that we have taken that it was equal to A upon B and there was no common factor between A and B. That means we have arrived at a contradiction. Therefore, our assumption is wrong. Our assumption was that root 5 is an irrational number. Our assumption was that root 5 is a rational number. That our assumption is wrong. Therefore, root 5 is irrational number. Okay. Question number 3, exercise 1.3, part 1. Prove that 1 upon root 2 is irrational and 6 plus root 2 is irrational. Now these questions will be done by using the method of contradiction. Let 1 upon root 2 is not irrational. First statement. Let 1 upon root 2 is not irrational. Therefore, if it is not irrational, therefore it should be what? Rational. Therefore, 1 upon root 2 can be expressed in form of P by Q. Now this means where Q is not equal to 0. Now squaring both the sides, you get 1 upon 2 is equal to P square upon Q square. Cross multiplying Q square upon P square. Q square is equal to 2P square, or simply Q square upon P square is equal to 2, or Q upon P is equal to 2, root 2. Now you see, Q is an integer, P is an integer. Now this left hand side is one integer divided by another integer, so it can be written as a rational number. And root 2 is irrational number. And rational number can never be equal to an irrational number. Therefore, we arrive at a contradiction. Hence, our assumption that 1 by root 2 is a rational number is wrong. Therefore, 1 upon root 2 is irrational. See this question now. 6 plus root 2. Again, we will use the same method here, method of contradiction. Let 6 plus root 2 is not an irrational number, therefore it should be a rational number. If it is a rational number, it can be expressed in form of P by Q. So you see root 2 is equal to P upon Q plus minus 6, that is equal to Q is the LCM here. P minus 6Q. So you see, P is a integer, Q is an integer, therefore P minus 6Q, that is also an integer, and Q is also an integer where Q is not equal to 0. So integer upon integer, that will be equal to a rational number. So this side is a rational number. And root 2 is irrational, we know. Because it's having a root over it. So irrational number. So root 2 is irrational number, and this side we have a rational number, and irrational number can never be equal to an irrational number. Therefore, we come to a conclusion that our assumption is wrong. Therefore, 6 plus root 2 is not a rational number, it is an irrational number.